Hello friends, welcome to my channel. Let's have a look at problem 92, reverse linked list 2. In this video, we're going to share a solution based on the linear traversal method. So first, let's read through the statement, and then let's analyze the procedure, and finally share the code. First, let's look at the statement. So given the height of a singly linked list and two integers left and right, so where left is less than or equal to right, so reverse the nodes of the list from position left to position right and return the reversed list. So here are two examples. Let's look at example 1. So example 2 actually is the edge case. So in example 1, the left is 1 and the left is 2 and the right is 4. So we are going to reverse 2, 3, 4 to be 4, 3, 2, and then we connect 1 with 4 and 2 with 5. So the output corresponding the value 1, 4, 3, 2, 5. So let's also look at the constraints or additional assumptions on this problem. First, the number of nodes in the list is n, and n is bounded above by 500, and the node value is in between negative 500 and positive 500, and the left and the right are valid countings, which is in between 1 and n. So this is the main problem statement. So here we are going to share a solution that is more verbose, but we targeted for a understanding of the details. So the procedure is as follows. So first, we are going to find the nodes corresponding to the left and the right countings. So here is not exactly index. So here all we can regard it as index counting from 1. So secondly, we do the reversing, and then we connect things together. So as we said, we are going to write with some redundancy just to demonstrate the technique or do the practice. So the first step is going to find the nodes corresponding to left and right. So for this, I'm going to first treat a special case. So the special case is that when left equals right. So in this case, so no reverse is actually needed. So we're going to return height anyway. So this is one case. So next, we're going to try to find the left and the right. So for this, because we also need to do some repointing or breaking the links, so I also need to use a previous variable. Let's call it none. And then we call left node and the right node to be a right node corresponding to the left and the right to be now. Then we just do a loop to find the corresponding nodes corresponding to left and right. So for this, I also want to use an IDX to track the counting, right? So let's try use another one called both found. So it's a Boolean variable. Let's call it false at the very beginning. So once we locate the right node, actually we can break. So currently is the height, and then we can do the while loop, while current and not both found. So in other words, if the current is still not null and we haven't found the two nodes, so we are going to continue. For each time, we are going to increment the index by 1. So this index actually is counting, right? So if IDX is less than left, so then in this case, we do two things. Actually, we first update the previous to be current, and then the current to be current next. So this is very standard. Otherwise, so we can check if IDX equals left. So this way, actually, we located the left node. So we are going to write left node to be current. So in this case, we actually have already found the correct previous. So in here, the previous is 1, right? So we do not need to update previous anymore. So this is just in the else block, we do not update previous. So left node equals current. So this is one condition. Another condition is if the IDX equals right. So in this way, we're going to set the right node to be current. And also, we want to change the flag. Both found to be true. So otherwise, so we just do one thing, that is current equals current next. So in this previous if, we do two things. Actually, we also track the previous pointer. So in the else block, we do not track the previous counter. So we just need to current update. So with that said, actually we were able to locate both the left and the right. And next, what we are going to do is break the links about the pointing relations to prepare for the reversal. So here, for example, we found 2 and 4. We need to break this one. Break the connection between 1 and 2. And also we need to break the connection between 4 and 5, right? So for this, let's do this. So we need to consider a special case if the previous is null. For example, the index is 1, so the previous will be none, right? So in this case, if previous, so we're going to set previous next and to be null. Not to be null, to be the right node next, right? Sorry, so to be the null, right? So this is null. And then we also need to set break this one. This will be pointing to the right node next. So the follow, let's introduce this one. It's we want to first denote that. So this is the right node next. You can think of the 5 here. So then we break the link between the right node and its next. So right node next equals none. So this way I have stored this follow so that later we can connect them together. So that's the thing. So let's see it again. So we break the previous with the left node, and we break the right node with its successor. So with this done, so we can do the reverse. So for doing the reverse, we can actually directly write the code, so without writing a function. But here, let's write a function to make it more modularized. Reverse the part in between left node and the right node. So this can be done actually using O1 space if we just modify the node, the linked list itself. But let's write this function just to make it more modularized, because we want to emphasize the technique of reversing a linked list. So this is actually very standard or routine. So to do the reverse, let's use a previous, let's call it none, and then the current is the current node, right? And then we're going to do a while loop, very standard. So first, let's get the next current, this current next, so that we can do the reset. So we want to point the current to the previous, right? So this current next equals previous. And once we done this, we can shift the P to be current and the current to be current next. So because we have stored the current next, so we can directly do the reset. So this next current plays a role of doing the transition. So once this done, so what we want to return is actually the previous. This will be the head of the reversed linked list. So with that said, actually now we are ready to connect things together. So here actually, so let's first do the reverse. Let's call the reverse after we do the reverse. So the reverse part of the linked list have a head that is left node. So after we do the reverse, so the made actually is corresponding to this 4, right? 4 will be the head, and 2 will be the tail, right? So in order to do this reverse connection, so first we check if the previous is not null. So if previous is not null, so we are going to do previous next to be the new head, that is middle, and then we're going to so anyway, so before we do that, we can always do this. So left node. So left node is currently the 2. So we're going to point next node, the left node next to be the follow, right? So this is always true, no matter the follow is null or not. So the second part, if the previous is null, so it's not null or null. So if it's not null, so we are going to point this previous to the head, or to the middle, and then return the previous. So otherwise, so if the previous is null, so we just need to return the middle. So corresponding to the case if the left index or left counting is 1. So this is a full solution format. As we stated at the very beginning, we are writing with certain redundancy to demonstrate the process and fixing the idea. So let's first do a special case check. Yeah, it passes the first example. Now let's do the generic case check. So it's an let's see what's wrong. Reverse left node if previous next middle and previous read. So here we're going to return hide. So let's do the generic case. Yeah, it passes all the generic cases. So let's give a quick summary of this solution, and then we end this video. So in this format of solution, actually we divide the current format in presentation into 4 parts. So the first part is to find the node corresponding to the left and right. So here, if we regard left and right as index, so we can regard them as one indexed. In other words, counting from 1. And then, so we break the necessary links to prepare the reversal. And in the third part, so we reverse the part in between the left node and the right node. So the fourth part is connect things together. So for this part, it's important, so we return the correct thing. For example, here we made a mistake, so we need to return the hide if the previous is not null. But it's so in this special case, the previous also is the hide. So if the index is 1, actually we just need to return the middle. So with that said, I guess that's about it for this video and for this solution. Thank you very much.